Okay, so welcome back. So in this video, we're going to do the same thing that we did before. So we're going to use M6 to estimate. So we're going to use 6 subintervals, right? So we're going to estimate, we're going to use the midpoint rule for 6 subintervals to estimate this, the area under this function, the integral of this function, or the area under this function over this interval. Okay, so again, first thing we need to do is we need to figure out delta x, and then we need to find our midpoints, and then we just plug and chug. That's really it. This is very straightforward, easy to do. Okay, so delta x is b minus a over n. And so in this case, a is 1 and b is 4. So it's going to be 4 minus 1 over 6, n is 6, which is going to give us 3/6 or 1/2. So there's our length of each subinterval. Okay, now this is going to help us get all of the partitions, the subintervals. Now, that means we're going to start with 1, and our first subinterval is going to be 1, 2, 1. Now this is the length, so we need to go 1/2 farther. So this is going to be 1.5. Oops, not a third. 1.5. And then our next subinterval is 1.5 to 2. And then our next subinterval is 2 to 2.5. And then our next subinterval is 2.5 to 3. And then 3 to 3.5. And then finally 3.5 to 4. Okay, so now what are our midpoints? Okay, now once you find the first midpoint, you just add the width of the subinterval, the length of the subinterval, each subinterval, to just get the next one. So we're just going to add 1/2. So once we find the first midpoint of the first subinterval, then it's just adding 1/2 to get the rest of them. So it makes things a lot easier to calculate. So you don't have to keep using the midpoint formula to find the midpoint of each interval, subinterval. Okay, so again, so the halfway point between 1 and 3/2. Okay, so we're going to do what? It's going to be 2 over 2 plus 3 over 2 divided by 2, which is going to give us what? So this is going to be 5/2 times 1/2, which is 5/4. So now what I'm going to do is 5/4 is my first one, and so now I'm going to add 1/2, or 2/4. So I'm going to add 2/4 to 5/4 to get 7/4. And then I'm going to add 2/4 again to get 9/4, and 11/4, and 13/4, and 15/4, and I'm done. So those are my midpoints. So I've got M1, M2, M3, M4, M5, and M6. So it works out. Okay, so everything works out, right? So again, if you do this correctly and you add, you should always start with the A and end with the B, and then all of your midpoints will fill out nicely. Okay? This is really straightforward and easy to do. You just have to practice and just work this systematically. Okay, now that we've got our midpoints, now it's just plug and chug. So let's do this. Okay, so let me put down our set of midpoints again. So it's going to be 5/4. Okay, there's our midpoints. So I'm just erasing so I can now I'm just going to use M6, which is going to be the sum equals I equals 1 to 6 of f of m sub I times delta x, and now I'm just going to plug in Chuck. So now this is the sum of, well, this is 1/2 m sub I squared times delta x, which is, delta x was what? 1/2. So now this is from I equals 1 to 6. Now here, these are constants. So I can pull the constants out of the sum. So I can write this as 1/4 times the sum of f of m sub I squared. Or, I'm sorry, m sub I squared. Okay? Now it just becomes 1/4 times what? 5/4 squared plus 7/4 squared plus 9/4 squared plus 11/4 squared plus 13/4 squared plus 15/4 squared. Okay, so now let's simplify this. Okay, so what does this become? This is going to be 25 over 16 plus 49 over 16. Hang on a second. So this is going to be 25 over 16, and this is going to be 49 over 16, and this is going to be 81 over 16, and 121 over 16, and this is going to be 169 over 16 plus 225 over 16. Okay, and now all we have to do is just add up all of the numerators. Okay, and we get 225, 380, 394, 395, 495, 515, 516, 596, 605, 645, 650, 670. So we get 670 over 16. Okay. And this cancels with this, and that gives us 335. And so that gives us 335 over 32. And I believe that's irreducible. And that's the answer. Have a good day.